Hey guys, my name is Shreyas and welcome to Simple Chemistry. Now, in the previous video, we talked about how Dalton's first postulate was disproven by Thomson by the discovery of the electron using the cathode ray tube and all that interesting things. And we talked about how that proved, that showed chemists at the time how atoms of the different elements were different because they varied in the number of electrons, which is great and all. However, Thomson did one major mistake, and that was his actual model for the atom. The plum pudding model that you talked about in the previous video is completely wrong. And we're going to be talking about the discovery of the nucleus, which shows a little bit more correct model of the atom. So we're getting there. I mean, we're going to see the mistakes chemists created in this atom too, but, you know, as we progress through this unit, we're going to see how the atom got closer and closer to what it is today. So just as a background, an alpha particle is a large positive particle. And we'll be talking about alpha particles later in this video, so make sure you know that. A large positive particle is an alpha particle, okay? Now, not all large positive particles are alpha particles. I'm just saying that an alpha particle is a large positive particle, okay? Didn't want to get you confused there, okay? And we're going to be talking about it, so just make sure you know that. So in the early 1900s, the scientist we're going to be talking about in this video who discovered the nucleus is Rutherford. But Ernest Rutherford decided to confirm Thomson's plum pudding model of the atom using his own experiment, okay? So he reasoned that if he shot alpha particles at a gold foil, they'd pass straight through. The reason for that is, let me see if I have a picture here. Here, okay. Yeah, so he reasoned that if he shot alpha particles at a gold foil, it would pass straight through, and they actually did something else, and that this experiment is now known as the gold foil experiment. In case you see this in your textbook, make sure it's called the gold foil experiment. So, basically, so what Thomson was thinking at the time was that, so this is a plum pudding model, right? So you have an atom, and it has electrons, scattered electrons, and then you have this diffuse spread positive charge in order to balance out the electrons. So what what Rutherford was thinking is that if he shot these alpha particles, you know, these large positive particles, at a gold foil, you know, which has atoms like this, they should pass through because this diffuse positive spread charge, you know, is not going to make the electrons go away. Since the alpha particles are traveling so fast, and since there's this diffuse, you know, positive charge, it's not going to really alter the path of those alpha particles. They're still going to be able to pass through. Okay? So he reasoned that, and he made a little setup like this. He has the alpha particle emitter, so that's the thing that shoots out the alpha particles. He has a beam, and he has a gold foil in the center, and he has this screen which detects the alpha particles. So he reasoned that, okay, they'll probably just go straight through the gold foil like this, okay? However, what happened was, in reality, they didn't just go straight through. Actually, what happened was some of these particles started to bounce off into different directions, and some of them came straight back into the alpha particle emitter, which doesn't make sense because Rutherford was thinking that, hey, like they should just pass straight through because, you know, the plum pudding model says that, you know, you have a diffuse positive charge, so it should just pass straight through. But what's happening here is he's saying some of them just bounce right back. So he knew that the plum pudding model had to be wrong after this. So he revised the model of the atom. He said that the large deflections of the positive alpha particles, so basically these things, just like everything's shooting off like this, must mean that the atom had a large positive area. You know, this diffuse charge, positive charge thing is wrong. You know, there has to be this large positive area in order for because if there has to be a large positive area, because that would explain how the atoms are, the alpha particles are shooting back, because these alpha particles must be colliding with the large positive area. So he called this the nucleus. So basically, he revised the model of the atom in order to make something like this, the nuclear model of the atom. So instead of having this plum pudding model where you have electrons and you have a diffuse positive charge, he switched it around. He said you have a nucleus, which is this a large positive charge, which is massive in the center of an atom, and then you have electrons dispersed through the atom like this. And that would explain how the alpha particles are shooting back, because some alpha particles, yes, they pass through the electrons, but some of them hit this nucleus, which is this large, massive positive charge area, and they came back. And this is a revised model of the atom, and this is also not true. He got the nucleus right, but the electrons dispersed through the atom aren't just dispersed like this. There's actually more to it than that. We're going to be talking about that in previous, in later lessons. But that's all you have to know about. All you have to know right now. The discovery of the nucleus is as simple as that.